This is the NavBlade Senior Design Project. NAVAIR is a United States Navy command that is under the Department of Defense. NAVAIR provides support for the United States Navy aircraft. There are 8 NAVAIR locations in the United States. The NAVAIR location that we work through is the Fleet Readiness Center in Cherry Point, North Carolina. In order to allow for safe movement of parts, support equipment is designed to secure parts for transportation and movement. Since some of these heavy loads have unique geometries, some support equipment has to be specifically designed to the part that they are moving. That is where our senior project comes in. Currently, on the CH-53E, a clamp placed on the main rotor blade holds the weight while it is removed from the main rotor. The blade is then moved over a transportation cart where it is manually turned 90 degrees in straps, usually requiring multiple artisans to secure it. To put the blades back on the main rotor, the same process is repeated in reverse. This process can be streamlined for a more efficient and safe operation. The blade is 28 feet long and weighs nearly 400 pounds, with the trailing edge of the blade being fragile. There is a risk of the blade falling out of an artisan's hands or the trailing edge of the blade being snapped. The main objective of the NavBlade Senior Design Project is to design a lifting device that can safely carry the blade and rotate it 90 degrees for installation on the main rotor and storage in the transportation cart. The final design has to operate with a minimum safety factor of 5 and be able to support a proof load of 2 times the blade weight, which is around 800 pounds. The initial 3 concepts for the lifting device consisted of 2 clamp designs that rely on chains and gears to manipulate the blade, and 1 design that uses straps. Ultimately, due to the scope of the project, our ability to fabricate the prototype, and efficiency, we decided that the strap-based lifting device would be the most effective design. To design the lifting device, we used Creo to create the models, and using SolidWorks, we were able to run FEA on the models to find the minimum safety factor, where the maximum stresses were, and how much it would displace from the load. Calculations were also done to ensure the blade stability in the straps, and what weather conditions will induce a blade slip in the straps. Once the final design was verified, the fabrication process began. We ordered all the parts, and once they came in, we began machining. To test the lifting device, we used a 2-ton engine hoist to hold the prototype and the weight. For the weight, we used 10 10-foot directional drilling rods, with each weighing 80 pounds. This gave us a proof load weight of around 800 pounds. Once we had the engine hoist lifting the prototype, we secured the bundled drill rods in the straps and slowly lifted the weights. When the prototype completed that test, we tested the rotation mechanism. We calculated that it would only take 6 inch-pounds to rotate the load, and it turned with ease. The final result is a 240-pound lifting device, which has a rotation mechanism that is robust and easy to use. Moving forward, the lifting device will be given to NAVAIR for them to implement in the current blade maintenance operation.